How to approach this type of problems? Whenever you see here tan inverse, the first target should be to convert this entire function in terms of tan inverse of a minus b divided by 1 plus a into b, because this entire term is equal to tan inverse of a minus tan inverse of b. So in this way, this entire term get reduced to tan inverse of a minus tan inverse of b. Now how to convert this entire function in this form? For that we have to make Welcome to daily practice. In this video I will explain you solution of the question that you can see on your screen. So I urge you to watch this video till end so that you will get complete understanding of each and every step of this solution. Before we begin, if you are new to this channel, do subscribe it, and if you face any doubt you can share it in the comment box or DM it to my Instagram handle. So let's start solving this question. Differentiate with respect to x. So we have to differentiate cot inverse of cot e raised to x square with respect to x. To solve this, let me show you solution. First we will assume the given function as y. Therefore y is equal to, now this cot inverse and cot will get cancelled, and what I will be left with, see, this cot inverse and cot will get cancelled, and I will be left with e raised to x square. Therefore y is equal to e raised to x square. Now this is a composite function of exponential function and algebraic function. Therefore we are going to use derivatives of composite function to differentiate this. Now differentiate with respect to x, then what I will get, dy by dx is equal to derivative of e raised to x square is e raised to x square multiplied by derivative of x square. So derivative of x square is 2x. So we have used chain rule to differentiate this composite function. Therefore on simplifying this, what I will get, dy by dx is equal to 2x into e raised to x square. So this is the final answer which is expected. So in this way we solve this type of question. Moving to next question. Differentiate with respect to x. Cosec inverse of 1 upon cos 5 raised to x. So we have to differentiate this inverse composite trigonometric function. So how we will differentiate this? First we will assume the given inverse trigonometric composite function as y. So y is equal to cosec inverse of 1 upon cos 5 raised to x. This cosec inverse I will convert into sine inverse. So sine inverse cos 5 raised to x. So in this way I have converted cosec inverse into sine inverse. While conversion from cosec inverse to sine inverse, we have to take the reciprocal of the term inside the bracket. So on taking reciprocal, what I have got, sine inverse of cos 5 raised to x. Now I will convert this cos into sine so that this sine and sine inverse will get cancelled. So what I will get, sine inverse of sine pi by 2 minus 5 raised to x. Now this sine inverse and sine will get cancelled. So I will get y is equal to pi by 2 minus 5 raised to x. And on differentiating this y with respect to x, what I will get, dy by dx. Now this pi by 2 is constant function, so its derivative will be 0 minus derivative of 5 raised to x. So 0 minus 5 raised to x into log 5 is the derivative of 5 raised to x. On simplifying, what I will get, dy by dx is equal to minus 5 raised to x into log of 5. which is our final answer. So in this way, we differentiate cosec inverse of 1 upon cos 5 raised to x. I hope you have understood each and every step of this solution. If that is the case, then give this video a thumbs up, share it with your friends, and don't forget to subscribe this channel. Now we have to differentiate cos inverse of under root 1 plus cos x divided by 2 with respect to x. So how to differentiate this function? We will assume this entire given function as y. Then what I will do? I will convert this term inside the bracket in terms of cos, so that this cos and this cos inverse will get cancelled, and we will be left with this term which will be differentiated with respect to x. Now how to convert this bracket in terms of cos? Let me show you. First I will write this 1 plus cos of 2. So now this 1 plus cos x is equal to under root of 2 cos square x by 2. Now on further simplifying, what I will get? This 1 upon root 2 into this root 2 multiplied by this cos square, and this root will get cancelled out. So what I will get? Cos of x by 2. This root 2 will get cancelled. So this 1 under root of 1 plus cos x divided by 2 will be equal to cos x by 2. So I will put this cos x by 2 in this bracket. So what I will get? Y is equal to cos inverse of cos x by 2. Now this cos inverse and cos will get cancelled. So what I will get? Y is equal to x by 2. And when I will differentiate this y is equal to x by 2 with respect to x, then what I will get? Dy by dx is equal to 1 upon 2 into 1. So derivative of y with respect to x will be 1 upon 2, which is our required answer. Moving on to next question. Differentiate with respect to x cos inverse of under root 1 minus x square divided by 2. Now this question is similar to previous one. What we have to do? We have to convert this term inside the bracket in terms of cos. How to do that? Let me show you. Now we all know that 1 minus cos 2 theta is equal to 2 sine square theta. We'll put 2 theta is equal to x square. Therefore value of theta will be x square divided by 2. So I will put 2 theta is equal to x square and 2 sine square. Instead of theta I will put x square upon 2. On dividing both the sides by 2, what I will get? Sine square x by 2. And if I take its square root, then what I will get? Under root of sine square x square by 2. And if I take this sine square outside the square root, then what I will get? Sine of x square by 2. So I have reduced this entire term in terms of sine. So I will convert this sine into cos. Cos pi by 2 minus x square by 2. Now I will put this cos over here. So what I will get? Y is equal to cos inverse of. Now I have successfully reduced the term inside the bracket in terms of cos. That is cos pi by 2 minus x square upon 2. Now this cos inverse and cos will get cancelled, and I will be left with pi by 2 minus x square upon 2. Now as we have simplified the given function, I will differentiate it with respect to x. Then what I will get? Dy by dx is equal to derivative of pi by 2 will be 0 minus 1 upon 2. Derivative of x square will be 2x. So this 2 will get cancelled and I will be left with dy by dx is equal to minus x, which is our final answer. So in this way, we differentiate the given inverse trigonometric composite function. I hope you have understood the approach that we use to solve this type of question. Now we will solve next question. Differentiate with respect to x. Tan inverse of inside the bracket 1 minus tan x by 2 divided by 1 plus tan x by 2. Solution. Now to solve this, we will first assume the given function as y. So y is equal to tan inverse of 1 minus tan x by 2 divided by 1 plus tan x by 2. Now how to approach this type of problems? Whenever you see here tan inverse, the first target should be to convert this entire function in terms of tan inverse of a. Here we have minus sign, so a minus b divided by 1 plus a into b. Here we have minus sign, so in numerator we will have minus sign, and in denominator we have plus sign, so here we will have plus sign. So our target should be to convert this given function in this form, because this entire term is equal to tan inverse of a minus tan inverse of b. So in this way, this entire term get reduced to tan inverse of a minus tan inverse of b. Now how to convert this entire function in this form? For that we have to make adjustments. Now how to make adjustments? Let me show you. Therefore y is equal to tan inverse of. Now here we have tan. So this tan after conversion will cancel out this tan inverse in this second term, whatever term we have. Similarly, we have to convert this term such that this tan inverse will get cancelled out from the tan which we have adjusted for the value of 1. We all know that tan pi by 4 is equal to 1. So what I will do, I will replace this one with tan pi by 4. This minus sign as it is. This tan x by 2 as it is. Divided by 1, I will keep it as it is, plus. Now here tan x by 2. This tan x by 2 is multiplied by 1. So I will put the value of 1, that is tan pi by 4 over here. So tan pi by 4 into tan x by 2. Here you can see that I have modified the given function in this way, such that we will be able to apply the formula for expansion of tan inverse of a minus b divided by 1 plus a into b. Therefore, expansion of this entire term will be tan inverse of tan pi by 4 minus tan inverse of tan x by 2. I have used this expansion. Now this tan inverse and tan will get cancelled out. Similarly, this tan and this tan inverse will get cancelled out. So what I will be left with, this pi by 4 minus x by 2. So in this way I have reduced the given inverse trigonometric composite function into an algebraic function. So now what I will do, as we have obtained the simplified form of the given function, we will differentiate it with respect to x. So what I will get on differentiation, what I will get dy by dx is equal to this pi by 4 is constant function. It will get reduced to 0 minus this 1 upon 2 as it is into derivative of x with respect to 1 is 1. Therefore, derivative of y with respect to x is equal to minus 1 upon 2, which is final answer. I hope you have understood step-by-step explanation that I have given you in this solution. If that is the case, then give this video a thumbs up, share it with your friends, and don't forget to subscribe this channel. If you face any doubt, you can share it in the comment box or DM it to me on my Instagram handle. So that's it for this video. See you in the next video. Till then, keep practicing.